Hey, math friends. So our learning target today is that I can estimate square roots and I can graph a square root on a number line. So let's talk about the idea of square roots. What is a square root? So square root is the inverse operation of a square. So for example, if we think of a square that has the area of 9, we know that what's special about the square is that the sides of the square are the same. So it would be like a 3 by 3 square that has an area of 9. So this symbol means if we undo the area, what's the side length? So 3 squared equals 9. So to undo, the square root of 9 equals 3. So we're talking about squares today and their side lengths. So square root, squares and side lengths. So we first have the principal square root. The principal square root is the perfect square roots. So if we take a square that has an area of 9, what's the side of that square? Well, it's 7 because 7 squared equals 49. Now notice I didn't write a square here at power 2, I just put 7. So we just want to know what is the side length. Then, if we have the square root of 1, well, what are the side lengths if we have an area of 1? So 1 times 1. So the square root of 1 is just 1 because 1 times 1 equals 1. So we're just looking at squares and the sides of the squares today. So negative square root just simply means opposite. Negative cannot be on the inside of the square root of the radical. So you can't ever have it on the inside. That would be an irrational number. But on the outside, we're going to just simply take the square root for negative square root, square root of 9, which I've identified as 3. That's a square that has a side of 3. And the symbol on the outside just simply means take the opposite of that. So what's the opposite? Negative 3. Likewise, square root of 144. Well, the square root of 144 is 12. Because the side of that square is 12 by 12. What's the opposite of that? Negative 12. So down here, I've given you kind of the things that we would call perfect squares. So 1, 4, 9, 16, 25. Those are perfect squares because it's 1 times 1, 2 times 2, 3 times 3, 4 times 4, 5 times 5. So the other ones would be 6 times 6, 7 times 7, 8 times 8, 9 times 9, 10 times 10, 11 times 11, 12 times 12, and so on. We could continue that process, but these are the perfect squares. So things that are not perfect squares would be the things in between. So we know that 1 is a perfect square, and 4 is, and 9, and 25, and so on. Because it's 1 times 1, 2 times 2, 3 times 3. I forgot 16. 16. Sorry about that. 4 times 4. And of course, 5 times 5, right? Those are the perfect squares. So the things that are not perfect would be the numbers in between there. So the square of 2, the square of 3, not perfect because they don't make squares. 5, 6, 7, 8, those don't make squares. 10, 11, 12, 13, 14, and 15 do not make squares. 16 does. These do not. 9 does, but these do not. 4 does, but these do not, and so on. So those are the non-perfect squares. Okay. So let's talk about how we would navigate this process then. So what do we do to estimate the perfect square? So we figure out what two perfect squares it's between. And then we will do a nice job estimating it after that. Sorry, I'm trying to find the correct page here. And there we go. Sorry about that. So Find the perfect squares it's between. So identify perfect square above and below. And then after that, estimate which one it's closest to. So 26. Well, 26 is actually a rectangle, not a square. Because if we think about what times what are the factors of 26? Well, 1 times 26 and 2 times 13. But none of those make a square because the sides aren't the same. So that's a rectangle, which means it's not perfect. But the square root of 26 is sitting right here. So identify the perfect squares above and below. We would say that the square root of 26 is between the square root of 25, which is 5, and the square root of 36, which is 6. So the square root of 25 is somewhere in between 5 and 6. And we're going to leave that for our answer today. That the estimate is somewhere between 5 and 6. And clearly, the square root of 25 is closer to 26. Sorry about the delay. I'm having trouble with my smartboard. So the square root of 26 is what I meant to say is pretty close to square root of 25. So our answer is going to be pretty close to 5, but we're going to estimate that we're somewhere between this integer of 5 and an integer of 6. All right, let's try that same process again. So I'm going to delete all this. And let's go through that same process. So we have the square root of 62. The square root of 62 lives right here between the square root of 49 and the square root of 64. And the square root of 49 is 7. And the square root of 64 is 8. So our answer lives somewhere between 7 and 8. And that's where we're going to keep it for today's work. Just kind of estimate the integers that it's between. The answer is somewhere between 7 and 8. So 7 point something. All right, let's try that same process again, estimating square roots. How do we do it when it's not a perfect square? So 6, not a perfect square. 6 lives right between here, between the square root of 4 and the square root of 9. And the square root of 4 is a square that has a side of 2. The square root of 9 is a square that has a side of 3. So the square root of 6 lives somewhere between 2 and 3. My answer would be somewhere between 2 and 3. Likewise, let's erase all this and try that one more time. What happens if it's negative? So negative, we're just working in that opposite side of 0. So the square root of 70 would sit right here. And now we're in negative side, so we're really talking negative square root 81, because that's smaller, and negative square root 64. So 70 is in between those. And we know that the square root of 81 is a square that has an area of 9, but the opposite. And we know that the square root of 64 is a square that has the area of 8, but opposite. So for the square root of negative square root 70, our estimation, since it's not perfect, it's not 81 and it's not 64, so our estimation that it lives somewhere between the somewhere between negative 9 and negative 8. Somewhere between negative 9 and negative 8 is the estimation of that. All right, so for the rest of our work today, let's take a look at page 2. Let's see here. I'm going to just kind of take a peek quick of what else I want us to do. Okay, so now let's talk some graphing on a number line. Okay, so hang in there, guys. We're already at that 9-minute mark. So let's take a look at the ones that we know for sure. So the square root of 4, we know that the square root of 4 is equal to a side of 2, which clearly is D. Right? So that's a nice perfect square. Square root of 11 is not. So square root of 11 lives between the square root of 9 and the square root of 16. So we know it's between 3 and 4 positive. And are any of those values between 3 and 4 positive? Yes, E and F. So we're not totally sure which one. Although 9 is pretty close to 11. So that's going to be my estimate there. 9 is closer to 11 than it is 16. So I'm going to say it's got to be an estimation of E. Now we can change that if it doesn't come out that way. All right, this next one, using a quotient property, it really becomes the square root of 1 over the square root of 16. That's what it becomes. Square root 1 over square root 16, which becomes the fraction. You'll learn that later in Unit 6, a little bit deeper of the y that is 1/4. So really super small, like 1/4 of a dollar would be 25 cents. So our estimation of that would be C. All right. So now let's take a look at some negative values. So negative square root 18 would be between the negative square root of 25 and the negative square root of 16, which would be between negative 5 and negative 4. Negative 5 and negative 4. And clearly 18 is closer to 16. 18 is closer to 16. So slightly closer to negative 4. So I'm gonna go with B is my estimation. Again, I can change that if something else comes up closer. So we have D, E, C, B. All right, so negative square root 23 would be between the negative the square root of 25 and negative square root 16, which we just practiced. And that works out beautifully because negative square root 23 is pretty close to the square root of 25. Again, we're just estimating. So the answer has to be a little bit closer to negative 5. And the one that's a little closer to negative 5 is A. Good. That worked out great. Because that's a negative 5, that's negative 4. So A. Awesome. So by default, we've used A, we've used B, we've used C, we've used D, we use E. So we assume that the last one is F, but let's just double check that. Now I'm going to erase some stuff just because it's a mess on my screen. So the square root of, sorry, I'm using a different pen today, so it's a little bit hard on the board here. So this between the square root of 9 and the square root of 16. And the square root of 9 is 3, and the square root of 16 is 4. And we're really, really close to the square root of 16, which is a 4. So of course, F would be my best estimate. So that's how we would graph square roots on a number line. A lot of like guess and check, it's not perfection there. Only one of those was a perfect square. So that's a good place if you're struggling to go back, pause the video, check it out, make sure you're in good shape. So the last part of the day, find the area of this square. Well, they just said it's a square, so that's 8. That's 8, that's 8, that's 8. So the area of that square would be 8 squared, which is 64 inches squared. That's area. We did the opposite of that today, which was what's the side length of the square. So we did today as well, if the area is 64, well, what's the side length? Which is exactly what we're going to do on the next question. Estimate the length of each side of the square. So we don't know the side of the square. So to do that, we have to take the square and take the square root. That's supposed to be an 8. It's just really hard to draw on the board. So what would be some perfect squares? Well, 81 is super duper perfect, close to 80, and 64. So we know that this square lives somewhere between those. And we know that the square root of 64 is 8. So that's a square with 8. That's a square with 9. And we know our answer is pretty close to 9. So somewhere between 8 and 9, if we were to estimate, we would say like 8.9-ish would be the side of the square. But somewhere between 8 and 9. That was what we did in our work today, was estimate. So for your summary today, what I'd really say is you got to think about the perfect square, the perfect squares. Having a hard time with this pen, sorry. Perfect squares. I'm trying to write it. So thinking about the perfect squares. So all the ones that make perfect squares, I give up on that. Let's go back to the screen so you can kind of see that summary. All of our perfect squares are these ones. And then we said 36 because it's 6 times 6 and 7 times 7 and 8 times 8. All the things that make perfect squares like 100 and 81 and so on, and 121, because those are those perfect squares. So that is what we use to try to estimate things that are not perfect squares. So that is our summary for today. Your job is to finish the next 2 pages, I believe pages 3 and 4 for our work today on estimating. You really shouldn't be using a calculator in that. You should be trying to figure out the estimation without a calculator, and it doesn't have to be perfect. All right, have a glorious night. Great job today. Reach out if you need anything. Make sure you reach out if you want me to go through some of those, because it's a little tricky when we're just estimating. We don't have this perfect answer that we're used to getting. Okay? Keep going. You got this. Have a good night.